I'm going to go over the answers here to the 6.3 quick check. We have three different problems, and they're all dealing with the enthalpy of a reaction, and we have three different techniques for this. So let's get started. The first one here says that what's the delta H for the combustion of octane, and it shows that it is given as negative 1368 kilojoules per mole, and that means per mole of reaction. So how much energy is released? So we want to find kilojoules, starting with 36.5 grams of octane. So we're going to start off here is to start with a 36.5 grams of octane. And then now we need a conversion factor to go from grams of octane to moles of octane. Okay, now let's go down here. Let's just do this. So we have C8, and we have H18. So we need 8 times carbon, which is 12.01 from the periodic table. And we have 18 times 1.01 from the periodic table. So this is going to be 96.08. And this will be 18.18. And we add it all together. We get 26 over here, 0.26, and 411, so 114.26 grams per mole. So I'm going to go back up here, put that in. I'll make it 114.3. Now that's how many moles, if I stop now, that's how many moles of octane I would have. Okay, now I want to say, well, for every 2 moles of octane, that's 1 mole of reaction. And the last part here is that every time there's 1 mole of reaction, as written, then we get the 1368 kilojoules of energy. Now here's that sign, whole idea about the sign again, that I can put in a negative here and I'll get a negative answer, or they're saying how much energy is released. And so we would actually say, well, a positive amount of energy is released. So we can do it either way. So if I do all my answers here, I end up with negative 218.5 kilojoules. That's my energy. Or I would say that 218.5 kilojoules of energy is released. So if I use the word released, then I don't need the negative sign, but either one of these would be correct. Second one here, it says, okay, find the delta H of reaction for this. Now we see that we are given all these delta H's of formation. So if I have these delta H's of formation, then I'm going to do products minus reactants. So my delta H of the reaction is equal to 6 times the delta H of formation of water plus 4 times the delta H of formation of NO2 minus 4 times the delta H of reaction of NH3 and minus 7 times the delta H of formation of oxygen. Now this one is going to end up being 0. That's why it's not even on our list, because making an element from itself, it takes no energy. So I'm just going to do water, NO2, and 4 NH3s. So I'm going to write this out for myself so I don't make mistakes. So 6 times the delta H of formation of H2O plus 4 times the delta H of formation of NO2 minus the 4 times the delta H of formation of NH3. Now I'm going to go back and put in numbers. So 6 times H2O is negative 242 kilojoules per mole of reaction, and 4 times the NO2 number, which is positive 34 kilojoules, and minus 4 times the NH3 number is negative 46. So if I go back and do these numbers, I get negative 1452 kilojoules plus 4 times 34, which is 136 kilojoules, minus a minus, so plus 184 kilojoules. And if I add all those up, I get negative 1132 kilojoules. And that's my answer. So again, it's products minus reactants, so the energy associated with H2O times 6, the delta H of formation for NO2 times 4, minus the delta H of formation of NH3 times 4. And do those together, and again, I don't need to use the the oxygens because element, their number would be 0. Okay, the last problem has to do with bond energies, and we can tell that because we're given bond energies at the bottom in our table. And we have to look at this, we have to turn these into what the bonds are. So N2, we know N2 is a triple bond. Hydrogen, there are 3 hydrogens, so I'm going to go ahead and draw 3 of these just to help our visualization. And then we have 2 ammonias, so we have 1 ammonia. I'm going to draw another one. Now I'm going to go back and color code. So what's going to happen? I'm going to break a nitrogen-nitrogen triple bond, and that's going to cost 418 kilojoules. Then I'm going to break 3 of these hydrogen-hydrogen single bonds, so I'm going to do 3 of those, so I'm going to use this number times 3. But what's happening is I'm going to make 1, 2, 3, 4, 5, 6. I'm going to make 6 NH bonds. Now what that does is I'm going to use this number, but since I'm making them, not breaking them, because bond energy is the energy it takes to break a bond, so I need to use the negative of this. So I need 6 times negative 391. Now let's give ourselves some room. So all we have to do is just total all this up. So I'm going to have 1 times 418 kilojoules. That's kilojoules per mole times 1 mole. So that's 418. And then I have 3 times 432 kilojoules. And that's going to end up being 1296 kilojoules. And then I have 6 times negative 391. And that gives me a negative number, negative 2346 kilojoules. So I have to add these all up, positive number, and negative number. And when I add those all up, I get negative 632 kilojoules. And that's my answer. So again, I just have to go by my bonds, but I have to remember I will use this number, the first 2 numbers, I'll use these as is because I am breaking those bonds. But the last one, I have to change the sign because I'm making those bonds. And that's how this works.